Hi, my name is Tyler, and this is my video on thermodynamic water tables. So let's kind of talk about pressure, temperature, get our feet wet a little bit before diving into the tables. Let's say we're camping and we're boiling some water, and I ask you what the boiling temperature of water is. You're going to say, that's really easy, Tyler. The boiling temperature of water is 100 degrees Celsius. And maybe I say, I don't believe you. Can you show me? Can you prove it? And so you come over here, you stick your thermometer in, and it rises, and it tells you that the temperature is 100 degrees Celsius. And this is true, but it's not always true. Let's say we do this exact same experiment, but we do it at 8,848 meters, the top of Mount Everest. This is you and me, and we just hiked all the way up. And we're tired, so we decide to make some coffee. And we find out that our boiling temperature, T, is much less than at atmospheric pressure. But how can we find out exactly how much less it is? Well, we can use these great things called the thermodynamic property tables. Now let's look at a problem. Let's find the saturation pressure at 100 degrees Celsius. So we're going to come to the saturated tables. You're always going to want to start with the saturated tables. And you're going to look for your 100 degrees Celsius. There we are. It's right here. And we find out that the saturation pressure is equal to 0.10135 megapascals, which we know is 101.35 kilopascals. But we also know that this is the atmospheric pressure, right? And this makes sense because the temperature is 100 degrees Celsius. So 100 degrees Celsius and a pressure of 101.35 kilopascals, the water will boil. This is what we know from our camping experiment. So let's find our boiling temperature at Mount Everest. Thanks to Google, I know that the pressure at Mount Everest is 33.7 kilopascals. So let's find our 33.7. We're going to come down here. Okay, 25, 30, 40. Oh no, our number lies somewhere in between here. What are we going to do? This is why we use interpolation. So interpolation sounds scary, but it's actually really easy. We kind of assume that there's a line that connects all three of our points, like a pressure and temperature function, let's call it. And basically, just these numbers are just going to be values on our curve. And the number that we're looking for will be, let's say here, and this will be the temperature that we're looking for. This is T and this is P on our pressure temperature function graph. So a little trick to this is you take this value from your table, subtract this value, divided by this value, minus this value again. So 33.7 minus 40, set that equal, we can put a big equal sign here. This value minus this value, 69.10 minus 75.87, divide that by this value minus this value. And if you do this, you'll never get interpolation wrong. So we'll find out that T is equal to 71.6 degrees Celsius. All you have to do is solve for your T. Okay. Now let's try and find a state using the tables. What state are you at given a pressure and given a temperature? So I suggest that you always use your pressure tables. Pressure, that doesn't look like pressure, does it? Pressure tables. If you start there, then you'll be comparing your T to some T saturation, which will be easier to do than comparing P's and P saturation. So we have a temperature of 300 degrees Celsius. We're going to use the pressure table. So let's take our 200 kPa, find it. So it's in megapascals, right? So 200 would be 0.2. This is our value here. So this right here is our temperature, 120.23. So let's come back up. So we're going to say this was 300, and this is 120.23. So our T is greater than Tsat, which means, like, if we can remember, this Tsat is actually the boiling point. And so if our temperature is much greater than the boiling point, what can we say about this? Well, we can say that the state is in fact a superheated vapor. And from this, you can use those superheated vapor tables to find stuff like specific volume, enthalpy, entropy, all those properties. Anyway, that's it for this video. Thanks for watching, guys.